Hey everyone, welcome back. Today, we are going to tackle two of the biggest and maybe most hyped ideas in tech, deep learning and neural networks. We're going to pull back the curtain and see how we're actually teaching machines to think. And the crazy part is, we're using our own brains as the blueprint. So, to really get why any of this matters, you have to start with this number, 2.5 quintillion bytes. I mean, that's a number so big, it almost doesn't mean anything. But that's how much new data we are creating on this planet every single day. And that right there, that's the billion-dollar question, isn't it? We're drowning in this fire hose of information. How on earth can we possibly find the important stuff, the patterns, the signals, in all of that digital noise? You see, the problem isn't just that the data is big, it's that it's unbelievably complex. Think of it like this. It's not just about having more and more rows in a spreadsheet. It's about having thousands or even millions of columns. More features, more variables, more dimensions. And this creates a roadblock for computers. A problem with a really cool name, the curse of dimensionality. So what does that actually mean? Well, when you have data with thousands of different features, like every pixel in a photo or every sensor on a self-driving car, the traditional ways of finding connections just completely fall apart. The data becomes so sparse and spread out that the old methods get lost. We needed something totally new. So, with computers hitting a wall, where do the pioneers in this field look for inspiration? Well, they looked at the best data processor ever created, the human brain. And they asked a really profound question. What if we could build a machine that learns the way we do? And that is the absolute key. This whole incredible field is built on one revolutionary idea. Let's make a digital version of the most basic part of our own intelligence, the neuron. And this is where it gets really cool. Just look at the parallel here. On the left, you have a real biological neuron. It gets little electrical zaps from its neighbors, thinks about it, and decides whether to fire off its own signal. And on the right, our artificial neuron. It gets numbers from data, processes them, and makes a simple decision. Do I pass this along or not? It's literally a mathematical echo of what's happening in our heads. All right, that's the theory. But how do you actually build one of these things? How do we go from this cool biological idea to actual lines of code a computer can run? Well, we start with the most basic unit. It's called a perceptron. Just think of it as a single, simple artificial neuron. Its only job in life is to look at a bunch of inputs and make a single yes or no output. That's it. And it does its job in 4 pretty straightforward steps. First, it gobbles up all the data, the inputs. Second, and this is the magic part, it applies a weight to each input. This is how it learns. It figures out which pieces of information are more important than others. Third, it just adds up all those weighted inputs to get a single score. And finally, something called an activation function looks at that score and decides if it's high enough to fire. It's like a tiny decision-making machine. Okay, so one of these perceptrons on its own is kind of limited. It can only make really simple decisions. The real breakthrough, the reason we're all talking about this stuff, is what happens when you link millions of them together in layers. Just like the billions of neurons connected in your brain. This right here, this is why it's called deep learning. It's not about one layer of neurons making one decision. It's about these extra hidden layers sandwiched in the middle. The first layer might learn to spot simple things, like lines and edges in a picture. The next layer takes that info and learns to see shapes, like an eye or a nose. And the final layer puts all that together to say, hey, that's a cat. Each layer learns something more complex than the last. And boom, that leads us right to the definition. Deep learning is all about using these neural networks with multiple layers, with depth, to solve those ridiculously complex problems we started with. It's using deep structures to understand deep complexity. So we've covered the problem, the brainy inspiration, and the tech behind the solution. But this isn't science fiction. This stuff is already everywhere, quietly running in the background of our lives. Let's look at just a few examples. I mean, just look at this list. Every time your phone unlocks with your face, or Facebook suggests tagging a friend in a photo, that's deep learning. The way Gmail magically knows what's spam, that's a neural network. Or how Netflix just knows what movie you want to watch next. Yep, you guessed it. It's even doing creative things like translating languages on the fly or bringing old black and white photos to life with color. It's amazing. So, if you take one thing away from all this, it should be this. We were faced with an impossible amount of complex data, that curse of dimensionality, and we solved it by looking inward. By copying the layered, interconnected design of our own brains, we've built something that can find the hidden meaning in all that chaos. Which leaves us with a pretty mind-bending question to think about, right? We've started teaching machines to learn and see the world in a way that's inspired by us. So what comes next? What huge, unsolvable problems in medicine or science or art are we on the verge of cracking open with this technology? The possibilities are pretty staggering.